Hey guys, welcome to my video on the first 3 problems in the Lasers of LASIK homework. Hopefully this video will help you get your brains back to first quarter into a units conversion frame of mind, because I was definitely hung up on hunting down equations for a little while before I realized that these problems just needed logic, and I definitely didn't feel the smartest, which is also exactly how I felt during first quarter physics. So that is definitely a bit of a throwback in that regard as well. So let's get going on the first part of the problem, and that's going to be problem number 1, which is about finding how many water molecule layers are vaporized by 5 pulses of the laser. And so here we have the information, and yours might be a little bit different. Mine is that the cornea is approximately 99% water, and approximately 0.25 microns of corneal tissue are ablated by 1 laser pulse. The question is, how many water molecule layers are vaporized by 5 pulses? And a water molecule length is approximately 0.1 nanometers. So, like I said, this is really a conversion problem. So you have 0.25 microns, which is going to be 0.25 times 10 to the negative 6th meters, and that is going to be equivalent to 250 nanometers, so essentially 10 to the negative 9th of corneal tissue. And excuse me if I misspeak or blunder. That's why I wrote everything down on flashcards beforehand. Those are hopefully a lot more clear. So we move on to step number 2. We've converted our corneal tissue to be in the same, and excuse my sniffles, to be in the same units as our water. And so we're then going to divide our 250 nanometers by the 0.1 of that thickness of the water molecules. And so we're going to have 2,500 water molecules vaporized by 1 pulse. However, we have 5 pulses, so we have to multiply that. And so we have 12,500 layers of water molecules vaporized by 5 pulses altogether. But I figured let's go on and do problem number 2, which deals with the relative power of the Excimer laser. And in my case, it was given to me as 60 milliwatts. And I'm told to assume that a pulse length is 10 nanoseconds. And then the question is, what is the energy delivered by 1 pulse? Again, we're just really looking at units. And so what are the units of energy? Anybody remember? They are joules, and joules are watts times seconds. We have milliwatts and we have nanoseconds, so we have to convert them and multiply, and that will give us watts times seconds, which will be joules. So as you can see, we convert our milliwatts into watts, and we convert our nanoseconds into seconds, and then we multiply the two that will take us into 60 times 10 to the negative 3rd watts times 10 times 10 to the negative 9th seconds equals 6 times 10 to the negative 10 joules. And that is the energy of 1 pulse, and that's going to be important later on. Not only in the next problem, but it's actually used several times throughout this homework. So you want to be sure to get this problem correct. So your conversions are pretty important throughout this entire homework. Anybody remember latent heat? So latent heat of vaporization of water is given as 2,260 joules per grams. How many grams can 1 pulse vaporize? And so your latent heat is 2,260 joules per grams. Again, remember, let your units guide you here. And then you already know exactly how many what your joules are for one pulse. And so you have your pulse energy in joules for whatever you calculated, divided by latent heat, which could be the same. I'm not certain if your homework gave it to you differently, which will cancel out the joules, as you can see in the setup down below. And then that will give you a final answer of the number of grams of water that is vaporized by one pulse. And so I hope that this helps everybody out.